Of vectors. Two vectors are equal if they have the same magnitude and direction. Good day, everyone. That's a very simple point that pops up once in a while when we are doing calculations on vectors. Then addition and subtraction of vectors using a few laws. Here, PQ, going from P to Q and then from Q to R, PQ plus QR is the same thing as going straight from P to R. So that means PQ plus QR is equal to PR. You can use the arrangement of the letters. PQ plus QR is equal to what? PR. Just like A plus B is what? C. So if A stands for vector PQ and B stands for vector QR, C is what? A plus B. And that's the same thing as, PQ plus QR is equal to PR. Take note of these two. Instead of adding PQ to what? QR. Let's say we are to do PQ, you understand, plus the opposite of QR, which is QS. PQ minus QR, which is minus B, will be equal to what? PS. So take note of that. So PQ, you understand, PQ plus QR is what? PR. But PQ plus what? Minus QR, which is the same thing as what? QS. So PQ minus QR, or PQ plus QS, because minus QR is standing for QS here. Minus B is the same thing as QS. So PQ plus QS is equal to what? PS. Just like, A plus minus B or A minus B is equal to D. Take note of the diagram here. A minus B. A minus B is equal to what? A minus B is equal to what? It's the same thing as D. So then we go straight to triangle. We go straight to triangle law of vectors. Triangle law of vectors. It says that if two sides of a triangle represent two vectors in magnitude and direction, the third side of the triangle represents their resultant in magnitude and direction. So let me use this diagram to explain my point. It's a two vectors U plus V are two sides of a triangle. Two vectors U plus V are two sides of a triangle. U plus V is equal to W. Can you see that? U plus V is equal to W. This is the same thing as saying if you go from this point to this point like this, and then go from this point to this like this, all that you have done is the same as going straight from this point to this point. So U plus V is equal to what? W. So take note of that. Very important. Let's go to the next part. So next is parallelogram law of vectors. This states that if two adjacent sides of a parallelogram represent two vectors in magnitude and direction, the diagonal of that parallelogram represents their resultant in magnitude and direction. The diagonal facing the two vectors represent their resultant in magnitude and direction. Let me state that again. If two adjacent sides of a parallelogram like this, A and B, represent two vectors, the diagonal facing those two adjacent sides represent their resultant in magnitude and direction. So that means A plus what? B is what? C. In the same way, B plus what? A is what? C. B plus A is also C. So, as you can see here, what it means is that the parallelogram law is just a variant. It's just another way of expressing the triangle law of vectors, and it's equally simple. So take note of that. Let's now go to addition of several vectors. If you go from A to B and to C and D, you understand? If you go from A to B and then to C to D from C, and then here and here, you will notice that your net movement is the same as going from what? Is the same as going from A straight to G. So going around like this, 1, 2, 3, 4, 5, 6, is the same as going straight from A to B. So the resultant of AB plus BC plus what? Plus CD plus DE plus EF plus FG is equal to what? AG. So take note of that. Let's now take a few questions as our example in this exercise before we go to some other parts of vectors. Examples. Number 1 here says, state whether the following physical quantities are scalars of vectors. Pressure is a scalar quantity. It has only magnitude, no direction. Electric current is a scalar quantity. It has no magnitude, no direction. We always add current algebraically when they meet at a point in a circuit. Conductivity is a scalar quantity. Only magnitude, no direction. Electric conductance, scalar also. E, frequency, scalar also. F, heat capacity is a scalar quantity. G, impedance is a scalar quantity. Impedance means total resistance in an AC circuit. Power is scalar. Power is also a scalar quantity. Torque is a vector quantity. If you have ever opened a door, you know what torque means. Torque is the turning effect of a force, just like moment. So when you open the door, you apply some force to open the door, and you can, go back and forth to close it back. So what you are doing is applying a torque on the door. You're applying a turning effect of force on the door. So torque is the turning effect of a force. We'll get to that later more. Latent heat is also scalar. Latent heat is also a scalar quantity. Let's go to question 2. Here it says, state whether each of the following quantities are scalars of vectors. So question 2 is the same as question 1. Excuse me. Number 1, surface tension. Surface tension is a vector quantity. It acts perpendicularly to the surface of a liquid. B, viscosity. This is a frictional force. Viscosity is frictional force between layers of a liquid, so it's a vector also. Reactance is a scalar quantity. It's a kind of opposition to the flow of current posed by a capacitor or an inductor in an AC circuit. We'll get to that later under physics. Resistivity is also scalar. Resistivity is also a scalar quantity. Resistance is a scalar quantity as well. Magnetic flux has direction, so it's a vector quantity. Magnetic flux has direction, so it's a vector quantity. Let's go to question 3. Let me change my ink to orange. Find the resultant of the vectors BC. Find the resultant of the vectors BC minus DC. Okay, I think there should be a comma here. Find the resultant of the vectors BC minus DC, comma, and minus FD. If I align my letters, starting from B to C, that's BC plus, if I'm looking for resultant, that means I'm adding everything up. So my resultant will be equal to, okay, let me try and make that. The resultant is the sum. Resultant is the sum of the vectors. Resultant is the sum of the vectors. So resultant will be equal to what? BC, take note, plus minus DC, take note, plus what? Plus minus FD, take note. But you know that minus DC is the same thing as CD. Just like if I draw a vector like this and this is AB. AB is pointing in this direction. BA is the same thing as minus AB, because BA is pointing in this direction. BA, let me use green. BA will be pointing in the direction opposite AB. But BA is the negative of AB. So minus AB is the same thing as BA. So in the same way, minus DC is the same thing as what? CD. So take note of that. Also, minus FD is the same thing as plus DF. You understand? Going from F to D. Minus FD. Going from D to F is the same thing as the negative of going from F to D. This is going from F to D. Let me try and explain that better. Going from F to D, this is the direction. So the opposite of going from F to D, which is minus FD, is going from D to F. I hope you get that now. The opposite of going from F to D is minus FD. And that opposite is the same thing as going from D to F. Is that clear? So that means minus FD is the same thing as what? DF. So take note of that. Very important. So, therefore, my vectors will be BC plus, instead of the second one B minus DC, I'll write CD, because minus DC is the same thing as CD. Then the next one, instead of it being minus FD, I'll write DF. So all of this will give me what? BF as my resultant. Do you understand? B, let me try and indicate with letters. BC, CD, arrows, DF. BC plus CD plus DF is the same thing as what? BF. So that means going from here to this place to this is the same thing as going straight from B to F. Very, very easy. So take note of that. That's question 3. Let's go to question 4. In question 4, it says find the resultant of the vectors AC plus 3BC plus CD. I'll try and be faster now because we are leaving the basics, so there will be less to explain. Then plus DA. Let me align my letters. The resultant is the sum, so I'm supposed to do AC plus what? 3BC plus what? CD plus what? 3CD plus what? DA. These are the vectors I'm supposed to add. So let me take it one by one. AC plus what? 3BC. AC plus 3BC. Let's just put that down first. Plus what? CD plus what? Plus CD plus what? 3CD. Okay, I think I've written that before and I'm supposed to. Let's go back and make some adjustment. AC plus 3BC. Let me just leave that. I'll compute that later. But I can put these two together. CD plus 3CD is 4CD. Because this is 1CD plus 3CD. So that gives me what? 4CD. So I have I've reduced my step now into AC, I've reduced my question into AC plus 3BC plus 4CD plus what? DA. Is that clear? Good. So take note that DA is the same thing as what? Minus AD. DA is the same thing as minus AD. Then DA is the same thing as minus AD. Then AC plus what? AC plus CD is equal to AD. Also, AC, take note of this addition here. Also, in the same way, AC plus CD is equal to AD. So from here, I can now change anywhere I have AC and 4CD. I will change it to what? AD. So AC, that gives me AC plus what? AC plus 4CD. Let me put the letters together. Let me just put them together, the similar ones. AC, rearranging, I'll get AC plus 4CD plus what? 3BC plus 3BC plus it's supposed to be AC plus 4CD plus 3BC plus DA, but instead of plus DA, I'll write minus AD. Is that clear? Because DA is the same thing as minus AD. So let's go ahead and make that adjustment. So my last vector here will be plus minus AD instead of writing this. So AC plus, look at this, AC plus 4CD is the same thing as AD. This 4CD is just a scalar. Just see it as AC plus CD. AC plus CD is the same thing as AD. So I have AD plus 3. I have AD plus 3 what? AD plus 3 BC left minus AD. Plus times minus here will give me minus. So minus AD. So rearranging, I'll get AD minus AD. Let's just put it together like that. Plus 3BC. So AD minus AD is 0. And my final answer will be 3BC. So that's how to do the resultant of the vectors. Let me go over it again just to explain more. This is the question. AC plus 3BC plus CD plus 3CD plus DA. First thing you need to note here is that 1 CD plus 3 CD will give you 4 CD. So I did that here. 1 CD plus 3 CD to get 4 CD. So instead of having 1, 2, 3, 4, 5 vectors, I now have 4. 1, 2, 3, 4. So keep that on one side. Also, I made this adjustment that DA, in order to align the letters in alphabetical order, DA is the same thing as minus AD. So instead of writing DA, in my next step, I'm going to write minus AD for DA. And AC here, AC plus what? CD. AC plus CD is meant to be what? AD. So I'll now rearrange. I'll bring AC to the front of, I'll bring CD to the front of AC. I'll bring CD to the front of AC. So I have AC plus what? CD to give me AD. I still have 3BC in the middle. Then instead of DA, I'll write minus AD. So if you put this together on rearranging, AD minus AD will give you 0. And your final answer will be 3BC. We call this vector algebra. It's very simple. You just need to Be careful while following the letters. The vectors A, B, and C are given by A is equal to 2I plus 3J. Okay, let me try and keep that on a single file. A is equal to 2I plus 3J minus 4K. B is equal to 5I. B is equal to 5I plus 4J plus 7K. Then C is equal to 6I plus 2J minus K. The question says find A, 2A plus 3B minus C. That's a simple question. That's 2 times 2I plus 3J minus 4K plus 3B, which is 3 times 5I plus 4J plus 7K. You understand? Minus C, which will be minus 6I plus 2J minus K. So you put this together, what will it get you? You will get 2 times what? I'm going to get 2 times A, 2 times 2I, 4I. 4I plus 6J minus what? 8K. Then plus 3B, that's plus 15I plus 15I plus 12J plus what? 21K. Minus C will be minus 6I plus 2J, minus 6I minus 2J plus K. So what I just did here is to multiply each of these by the constant outside. 2 times 2I, 4I, 6I minus 8K. 3 times 5I, 15I. 3 times 4J, that's what? 12J. 3 times 7K, 21K. This will turn to minus 6I minus 2J plus K. So I have that now, and I'm going to put all similar terms together. 4 plus 15 here, 4 plus 15, 19 plus 6, 25. So that's 25I. 25I. 6 plus 12, 18. 18 minus 2, 16J. Then minus 8 plus 21 is what? Minus 8 plus 21, that's 13. 13 plus 1, 14. Plus 14K. Is that clear? So you take note. What else do we get here? Okay, Roman numeral 2. Roman numeral 2 says we should find A minus 2B. A minus 2B plus 4C. That's what? Very simple. Let's write A down. 2I. I'm going to do it, in a single file now. That's 2I plus 3J minus K. Let me try. Okay, let's leave it like that. Minus what? Minus 2 times 5I plus 5I plus what? 4J plus 7K, that's minus 2B. Then plus 4C. Plus 4C is what? Plus 4 times 6I plus 2J minus K. So if you put this together, A is what? 2I plus 3J minus 4K. Minus 2B will be minus 10I minus 8J minus 14K. A minus 2B plus 4C is going to be plus 24I plus 8J minus 4K. So put all the i's and j's together. 2I minus 10I, that's minus 8I plus 24I, 16I. This 3 minus, plus 3 minus 8 minus 5. Minus 5 plus 8 is what? Plus 3J. Here too, minus 4 minus 14 minus 18 minus 4, minus 22K. That's the answer to question B. So you do this as your exercise, classwork or class exercise. Do question 3. Do question 5. Do question 5, Roman numerals 3 and 4 yourself. And as your assignment or homework, let's make this a homework. So as your homework, you do questions 6 and 7. The whole of questions 6 and 7. Let me see what's in 8. Okay, as your homework, you do the whole of questions 6, 7, and 8. It's the same thing. They've just written this in column form. So this is 1i plus 3j. A here in question 8 is 1i plus 3j minus k. B is 2i plus 3j minus 4k. And C is 1i minus 1j plus 1k. So you take note of that. Answer questions 6, 7, and 8. The corrections to each of these exercises the corrections for each of these assignments will be in the next video at the beginning.